Hello and welcome back to Calculus 1, section 2.4 on infinite limits. Now, what does it mean, the infinite limit? It means that the answer is going to be one of the infinities, positive or negative. So we said last time, that limit is the fancy way to compute y value. And you get some number. We did few examples. We got different values as answers. So now, what we are looking for today is that as you take the limit, x goes to some value a of f of x, you are going to get either positive or negative infinity. So that's what we are shooting for. So what would be an example? Well, y equals 1 over x, and then you look at the limit, x approaches 0 plus of 1 over x. Well, the answer for that is positive infinity. Why and how? Well, you know the graph for 1 over x, and you see that as you approach from the right, that's your 0 plus. As you approach 0 from the right, the y value shoots up to positive infinity. So this is what the infinite limits are all about. You are working on just regular limits, and this time your answer is either going to be positive or negative infinity. Another example, limit x goes to 0 for, let's say, negative 1 over x squared. So if you look at the graph, you know what the 1 over x squared looks like, and then because of the minus it will be flipped on the x-axis. So now you are looking at this graph and you see you approach from the left, it goes to negative infinity. You approach from the right, it goes to negative infinity. The theorem we learned yesterday is if they agree, then the overall limit is also the same, so negative infinity. So the answer would be limit x goes to 0 of negative 1 over x squared is equal to, say, negative infinity. Yes, so they're both going down negative, and they go forever, so that's a negative infinity, and therefore we claim that the limit is negative infinity. So infinite limits have infinity as an answer. Now, what limits? Well, all of them. Left limit, right limit, and overall limit. So one-sided and the two-sided limit, right, they all need to have an infinity in order to be considered infinite limits. Now, the application of this is extremely important, and the reason actually why we learn infinite limits. And that application is vertical asymptote. So you learned about vertical asymptote in your pre-calculus course or algebra course, depending on what you took, what the name was. And you learned that the vertical asymptote is the vertical line which function cannot cross. It has to approach, right? But it cannot cross. And it approaches it forever. Function always getting closer and closer and closer to asymptote without ever touching it or crossing it. And you learned a whole bunch of rules and regulations about that. And none of that stuff was actually complete because you need the limit to properly define vertical asymptote. So the question is, I will define it later. I'm just going to ask a question first, and then we'll define stuff. So the question is, if I have y equals 3 over x minus 4, do we have a vertical asymptote in? If so, what is it?
4.
4. Why is it 4?
Because x cannot be 4.
X cannot be 4. Now, how do you know that?
Because of the negative denominator here.
Okay, great. So you're telling me that x cannot be 4, therefore there is a vertical asymptote at x equals to 4. And you are 100% correct. Perfect. Now, in your pre-calculus and your algebra courses, you learn that you set the denominator to 0 to find these bad points, and then when you set the denominator to 0, then you can find this. But that's not all of the story. Observe this problem, this function, y equals x minus 5 divided by x squared minus 25. Vertical asymptote, yes?
Vertical asymptote would be 5. No, wait. No, it would be, yes?
Would it be?
Yes.
What's 5 squared?
25.
25, 25 minus 25, so 5 is definitely a problem point. Anything else? Yes?
-5.
Negative 5. So,
Yes.
so see, this is a trick question, right? Because I'm a terrible person. I haven't defined the vertical asymptotes yet through calculus, and we purposely do not put questions like this in a pre-calc because the only tool you have at that point in life is set denominator equal to 0. If you set denominator equal to 0 in this case, you will get plus and minus 5 as your vertical asymptotes, but positive 5 is not a vertical asymptote actually. And we'll see why, yes? Yeah, and it will cancel, and then you will not have infinity in the limit. So see, there is a lot of analysis that you are adding to your knowledge from pre-calc. A lot of new analysis that you're adding in calculus and things that you have to be careful about. So that old knowledge you have, we're still going to use it, but we have to upgrade it to the level where the calculus sits. So in this case, I'll just say, hold on. Because I want to first define the vertical asymptote, and then I'm going to go back and solve this question when I have a proper definition through limit. Okay, so vertical asymptote is a vertical line which is a vertical line where vertical line, let's go like this, vertical line x equals a, where limit x approaches a minus of f of x is equal to plus minus infinity, or limit x approaches a plus of f of x is equal to plus minus infinity, or limit x approaches just a of f of x is equal to plus minus infinity. Now, obviously, the easiest is to just check one-sided limits. So this is your definition for vertical asymptote. If you have candidates for vertical asymptote, in our previous example there, candidates are 5 and negative 5, you will use those in a limit. So you will check 5 minus or 5 plus, whatever you want, and then negative 5 minus negative 5 plus, whatever. Whatever gives you infinity, That's an asymptote. Whatever doesn't give you infinity, it's not. So now we can go back to our question that we know the definition. And we can say, okay, y equals x minus 5 over x squared minus 25. When I set x squared minus 25 to 0, this is what we learned in pre-calc, set the denominator equal to 0, we will get x squared equals 25, from where x is equal to plus minus 5. So it's a quadratic, right? So it has two solutions, and one is positive and one is negative. So now, these are my candidates for asymptote. They are not guaranteed to be asymptotes. These are just candidates. So what am I going to do? Well, I am going to now check. And to check for vertical asymptotes, we use the definition. Calculus definition, limit x approaches 5, we can do minus, right, from the left, of x minus 5 divided by x squared minus 25. So this is the way calculus would check if what you think is asymptote is actually an asymptote or not. Now to solve this, what should we do? We are factor the denominator, good.
Oh,
Then these puppies will cancel. And now, when x goes to 5, what do we get? 1 over 10. Is that an infinity? No. So let me write here in blood. Not plus minus infinity. So x equals 5 is not a vertical asymptote. So this is the way the analysis goes in calculus, right? You will do what you are trained to do in pre-calc, which is set denominator equal to 0. You set denominator equal to 0, and you find numbers. These are your candidates for asymptote. Now, calculus through limits clearly defines that the vertical asymptote is happening at x goes to a, at a, if the answer through the limit is infinity, positive or negative, whatever. So, we put in 5 minus here, and when we solve the limit, we get 1 over 10. Now, 1 over 10 is not infinity, which means it violates definition for vertical asymptote, which means it's not a vertical asymptote at 5. And that's why we have what we have here. We calculated that the value, the y value at 5 is 1 over 10, not infinity. Therefore, we do not have asymptote at 5. Now, we're going to check the other one. Limit x approaches negative 5, say minus, of the same x minus 5 over x squared minus 25. So now for this one, we have limit x goes to negative 5 minus. We do the same factoring canceling. And now, we have to worry about limit x approaches 5 minus of 1 over x plus 5. If you plug in negative 5, it's supposed to be a negative 5 minus, there we go. If you plug in negative 5, you get 0 in denominator, which means we cannot plug in, right? So what should we do? Well, there's no more algebra. You can't factor this. You can't, right? We're done with algebra. We graph it. We know the way to graph. What is the plus 5 going to do? Shift left 5. Good. So, we have to graph 1 over x, shifted 5 units left. Now you want to approach from the left. That's a red Juliet approach, right? You approach from the left, and what's the answer? Negative infinity, because it goes down forever, right? As your x value approaches -5, the y value, which is the value of the limit, the y value shoots down to negative infinity. You see the way the line goes. It goes down forever. So, in this case, yay! We do have vertical asymptote, right? The definition is requiring of us to get one of the infinities. We got a negative infinity, therefore, yay! X equals -5 is a vertical asymptote.
And I'm assuming it's the same thing that if you're going to do the limit of x towards -5 plus, it's going to be equal to, right?
Well, yes, because you would approach from this side, and then it will be positive infinity, but it's still infinity, right? Because for asymptote, you can get either or. Now you have to give both options because some functions, like square root of x, it starts at 0, right? It just abruptly starts at 0. It's not, there's nothing, you know how most of the functions drag on forever to the left, forever to the right. So you have to have left limits and right limits, and whichever one you pick, right, that applies, you should use it.
Should we put a, make sure that there's, what do we call it? Put an open circle over 5 here.
Yes, very good. I was about to, what I'm doing right now is I just went to Desmos to pitch a little bit more about them not having the open circles. But if you graph this function, right? If you graph this function, you will see that there is only one vertical asymptote. And this is your way to check. So if I have x minus 5 divided by x squared minus 25, you can see an asymptote at -5, and there is no asymptote at 5. They need to have an open circle here. They don't. And if you are really, hurt by that, please write them a strongly worded email, because that accomplishes a lot. Yes?
So, if the limit approaching limit x approaching -5 minus limit x approaching -5 plus, it's negative infinity approaching minus positive approaching plus. So the overall limit technically doesn't exist, right? Because they don't agree.
That's true. The word that I use in definition is or, right? So, right, it's not and, it's or. So it's not a requirement for overall limit to be one of the infinities. It's anything, any limit, any of the three. If any of the three is any type of infinity, it's an asymptote. It's really loose in that sense, right? Is that because what you were talking about is and that's more restrictive, right? License and registration. It's not really, right? Because in comparison to license or registration or library card, whatever you have is going to be fine. Does that make sense?
Yeah.
Right? So the definition clearly says or, right? And that means just one of them. Get one of them to be infinity, you're done. Yes?
Why do we need an open circle for
Because the +5 would still, original function, looking at the original function, +5 still makes 0 in denominator, and we can't have that. So +5 doesn't work in the equation at all as a function. As a point. So we have issue problems, right? We have issues and problems at both negative 5 and positive 5, but they're of different nature, right? In this case, of a negative 5, we have asymptote. On the other case, we have open circle. So if you, and you should draw this in your notes now next to the problem, just make sure you put did you put the open circle over here?
Yes.
Make sure you put the open circle on a 5 so you have a complete picture of what's going on. All right. Good. Please, guys, use Desmos as much as possible to graph these things and verify your answers. Limit is simply the y value for the x that you are computing. If I ask, what is the limit at negative 4, you will just look at the graph and you will say, oh, it's 1. Because that's the y value. There is nothing special, nothing extraneous happening at negative 4. We don't need any witchcraft to figure out that limit. You just look at the graph. Because at this point here, pre-calculus and calculus match 100%. You are only not able to plug in and calculate limit at these 2 points, negative 5 and 5. If I ask the same function for any other point, you will be able to plug in and just get the y value and be done. So your pre-calculus and calculus match everywhere except at these 2 points. Your pre-calculus answers for these 2 points doesn't exist. Calculus reveals the asymptote, and also calculus reveals 1 over 10. If the value existed, it would be 1 over 10. So the point that is open circle is 5, 1 over 10. That's the point. It's missing, right? Because we cannot have 5. So that's why it's open circle. We cannot have 5 because the denominator would be 0. But in the whole picture, right, pre-calculus cannot determine the value of that non-existent point, while calculus can. Now, I do want to ask and see who was paying attention yesterday, why? Why is the limit able to tell us exactly 1 over 10, and why pre-calculus cannot? I know I said that yesterday. The difference between pre-calculus and calculus in computing the value. What was it?
I believe that had to do with the table, didn't it?
Yes, it has to do with a table as well.
Allows you to calculate more specific values down to multiple.
You are getting closer, exactly.
Should I check in my notes? See if there's
You
anything
can.
down here.
So why are limits able to compute this 1 over 10? So pre-calculus can't compute because the value is not defined, right? Great.
Yeah.
Now, why are limit able to compute this? I said that.
All I have is a note about
No, sir?
Calculus isn't able to do it because the value is not defined. Make it defined.
Well, the value is not defined in calculus. If it's not defined, it's not defined. Yes?
You mean like you're calculating all the values leading up?
That's it. Yes, that's what you wanted to say too?
right.
So, calculus is computing the limit everywhere around 5, never computing at 5, where pre-calculus computes only at 5 and nowhere else. So if you carefully look at the graph, if there was an open circle over there, if you carefully look at the graph, you would see that your the open circle at 5, right? The only 5 is missing. All of the other values before and after 5, they all exist and you can compute at those values. So we make the inference on what the value would be, and that would be 1 over 10. Great. Woohoo.
All right, I have that in my notes then.
You have it? Good. So this is our definition for vertical asymptote, guys. This is our definition for vertical asymptote. You only need to get one of the 3 limits to go to infinity at that point A that you are suspicious of. And if you get infinity, A is a vertical asymptote. If you get a value, then it's not. Simple as that. Is there really anything else that we need to talk about? So we use the undecided limit, all that stuff, algebra factor, we did that. Good. So now, the issues that we face. Dividing by zero. This is something that we can finally talk about. You heard for years, make sure you don't have zero in denominator. You can't divide by zero. And that has been said so many times. Some of your teachers, professors might explain some basic ideas of why you can't divide by zero. And I can actually show that. Let me just get all of these. All right. So let's just do this experiment real quick, and then we'll take a look at an application, and we're done. So I have one group of 6 markers. So if I have 6 markers divided by, in one group, I have 6 markers in that group. Well, that's common sense, right? Now, I would like to divide 6 by 2. That means I'm creating 2 piles, and I keep assigning markers until I run out in each of the piles. So now, if I take 6 markers and divide into 2 piles, each pile will have 3 markers, and you can clearly see that each one of these groups has 3 markers in it. If I want to divide 6 by 3, I will create 3 piles, and then keep assigning markers until I run out. Well, that one is lost forever. And as you can see, 6 divided by 3, I have 2 markers in each pile, so 6 divided by 3 is 2. So that's what division means. You are creating real, physical piles to put things in it. Can you take, well, I'm going to do exercise 1. That's for the week. So now I have one group of 6 markers. Is it physically possible to put these 6 markers into no groups? Right? You have to have one group, or 2 groups, or 3 groups, or 4 groups, or 5 groups. You cannot have 0 groups. Because when you put everything that you have on a pile, you have one pile. You can't have less than one pile, right? So you can't divide by 0 even in the physical realm, because you are not going to take the one group of 6 markers and somehow distribute that over 0 groups. It's impossible, right? So we say division by 0 is not possible. Now, the concept that we have seen right here is far scarier than, oh, I just can't do it. Because when you plug in a -5 in denominator, you get 1 divided by 0. And the answer was infinity. You divide 1 by 0 and you get infinity. Now, I'm not sure how much experience you have with electricity, but if you short circuit the outlet, what happens? No, it goes, it explodes, right? It doesn't explode as a nuclear weapon, but it's a small explosion, right? Why? Why is there a small explosion? What's happening? Well, physics. So, we're just going to take a look real quick at the concept we just learned. So, your current, which is denoted as I, is voltage divided by resistance. And the voltage is 110 volts, it's 118, but 110 volts divided by resistance. When you plug in your cell phone charger or TV or whatever you're plugging in, the two prongs are through the wire connected to this coil that will make the other coil and transfer the voltage and so on. This coil has resistance because there is a lot of wire. So these moving electrons that create electrical current have to move through a lot of wire, and since they are moving through the medium, there is resistance. Is it easier to move through the air or through the water? Through the air, right? Because less than. So if you have a lot of density and so the properties of materials we don't need to talk about it, but the resistance is important, and any device that you plug in has a lot of that wire coiled, a lot of it. You can take one apart and see it actually. And if you want to unwind that wire, it will take extremely long time, and you end up with mile wire. All right. So it's very thin and breaks easily, but whatever. So now, if you replace this high resistance wire with a simple loop, which is very short, and you plug it in, then you are saying that this resistance is going to zero. Now, we just seen in a previous example that if your denominator goes to zero, your answer to the limit is going to go to infinity. So if I say limit of resistance going to zero of 110 divided by R, the answer would be infinity on this side. And that's the current. Current, there is a formula in physics, is proportional to temperature. So the higher the current, higher the temperature. Have you ever touched a wire of something that is plugged in and it was warm? Yeah. So that means that a lot of current is moving through that wire, which is why wires are rated 15 amps, 20 amps in the walls, going to the fuse, which is the same, the circuit breaker, which is of the same rating. Now, what do idiots do? So they keep plugging stuff in, and the switch keeps popping up, right? And they said, well, it's only 15 amps. Let me replace it with 20 amps. Oh, really? Because I don't recall you switching the wire in a wall from 15 to 20. That's how you burn your house down. Because, right? The breaker is supposed to switch it off when you reach the current temperature that the wire can withstand. If you go over that number, right? Okay, good. So, you either learn the stuff or don't play with it. It's very simple. So, the reason why you have a little explosion is because the current is trying to reach infinity in that short period of time, and we know that high temperature is a little bit of fire, right? So that's why you have all of those explosions and sparks and everything else happening, just because, and it is today's limit that we learn that actually covers that physical concept. And that's that. That's all we have. So for limits, for infinite limits, we are looking for the answer to be infinity, and then we use that as a vertical asymptote, and here are the words or, right? One of the limits, if any of the limits is infinity, whether it's positive or negative, you have a vertical asymptote. In this case, where we tried, we did not get infinity, it was an open circle, so maybe I should add that. Open circle at 5, 1 over 10. There we go. Now that's part of the notes as well. So no vertical asymptote because we did not get infinity. However, for -5, we did get infinity, so -5 was an asymptote. And now you have a whole bunch of different problems to try, whether you are working with fractions, you're working with factoring and canceling, or whatever other method from previous section, right, to solve the limit. This section is not teaching you limits in terms of solving limits. This section teaches you concept, which is if the limit gives you infinity, you have asymptote. If it doesn't give you infinity, you either have a point or open circle. So that's that. Well, that's it. Bye.